What'd you say?
No, I'm saying I gotta pay him back.
Pay who back?
So,
Oh, you owed him $10?
yeah, 5. Yeah.
Sophia's gonna make it ring. With the $10.
5 times what? You can't buy anything with me.
uh, anyway, so so this is also known as um there's another name called modulus. So first of all, you can figure out plot. You know how to plot the complex number. You have to know how to plot the complex number. If it's 2, just go to the right. If it's -2, it's going to the left. If it's a positive 2i, then it's going to up, and -2i is going to go down. And you can decide which quadrant it is. Then can you find the modulus, right? Now we're going to talk about, can you find the polar form of a complex number? Now this one is actually not hard because you did that before. So we're gonna call the complex number as z, and it's gonna be r cosine of theta plus r sine of theta I. Yeah.
I got a master class in the section.
Which one? Oh, you're right. It's -2 squared. But it doesn't matter. Yeah. Yeah, you're right. It's b is -2. So she says b is -2. She's absolutely right. Okay, so then you say, wait, what is this? This looks very complex. It's something you already know. Remember, this is what? X. This is y, right? So remember, r x equal to r cosine theta, and the y equal to r sine theta. So we already know this. So can we represent this? Well, we know 2 and -2. That means what? Tangent of theta is equal to -2 over 2, which is tangent theta is equal to -1, which is theta is equal to what? 3 pi over 4 and 7 pi over 4. Which one's better though? 7 over pi over 4 is better, or theta is equal to 3 pi over 4. So I'm going to pick 7 pi over 4 here. So this complex number can be represented as this. 2 root 2 cosine of 7 pi over 4 plus 2 root 2 sine of 7 pi over 4 I. So z equal to 2 minus 2i can be represented in this polar form. This is called polar form. But basically it's something you've done before. It's not nothing crazy. Ten data is to find out what is this data is. Actually, the data should be the other way. The data should be from here to here. This is data, which is based on y and x value of the triangle, of this triangle. This is -2, right? Sure. Am I going too fast, or you guys understand? Okay, so this is not, there's no different than before. It's very close to each other. So I'm going to ask you to find this one. So can you find the polar form of -1 minus square root 3i? Can you find the polar form of this? Draw it out first. Make sure you know the quadrants. Can you find a polar form of this? You're not slow. Maybe careless, but
For the root three, how like where does that go on the y-axis? Like how low is it?
it doesn't matter. It's root 3 is about 1.7.
So
Root 2 is about 1.4. Root 4 is 2, so it's between 1 and 2.
how do you figure out the distance?
You can use root 3 as a number. Using Pythagorean identity. Root 3 squared is what?
Just
Yeah. And what is 1 square?
Just
And therefore, what's the modulus, which is the absolute value of that? Yeah. And then you gotta figure out the angle as well, direction angle. You know how to figure out that. It's not like this is something you never done before. It's something you've done before, but just now it's in terms of complex number. Before it's in the polar coordinates.
Pi over 3? What else? Negative or negative? Because negative and negative is the tangent pi over 3 is square root of 3. It has to be like negative and positive. It has to be in each.
Hey, that was 1 and 3. 1 and 3. But why do you say this is quadrant? This quadrant is 2 and 4.
Like from my view.
Yeah, but it's not 2 and 4. It's 1 and 3.
Yeah, but not.
he was talking about the other problem.
Oh, okay, okay. This problem is 3.
Yeah, it's not.
Afternoon, yeah. Either this Saturday or next Wednesday. Monday's actually not bad. Monday's okay too. Oh, okay, that's fine. Yeah, that's stupid anyway. You will. All right. Shh. First of all, figure out the modulus, which is the modulus of -1 minus square root through I. This is a A, this is a B. But if you draw it out, you actually see what happened. If you draw it out, it is a -1. So we're gonna say -1 is right here. And -3i is about 1.7, so it'll be negative root 3i right here. So it's actually in the third quadrant. Does everybody understand that it's in the third quadrant? Now, obviously, you can figure out what the distance is. Now, just understand this is a root 3 negative, and this is a 1 negative. So it'll be -1 squared plus root 3 squared equal to square root is equal to z, the absolute value of z. So absolute value of z in this case is going to be square root of 4, which is 2. So that means you remember before we called it r rather than z. R is the distance from the radius. The same way. So R and Z are identical in this case. So R and absolute value Z is identical. So then you say, okay, well, now I find out that's 2. I just need to find out the angle from here to here, which is tangent of theta is equal to negative root 3 over -1, which is root 3 tangent theta. When's tangent theta equal to root 3? 4 pi over 3 and what? Pi over 3, right? But which one's better? 4 pi over 3? Okay. So then z equal to r cosine theta and r sine theta I plus this is just a y and this is an x. So there, oh sorry, this is x, this is y. My bad. So therefore it's gonna be root and the cosine of 4 pi over 3 plus 2 sine of 4 pi over 3 I. And this is called a polar form of the coordinate. Now, if you want to convert back to rectangular form, it's not bad. Just distribute. So it'll be 2 times, what's cosine of 4 pi over 3? -half. So this cancel out, right? Plus 2 sine of 4 pi over 3 is square root 3 over 2 negative, right? So that's cancel out. It's still going to be -1 minus root 3i. It's same thing. So this is called a polar form. And this is the rectangular form. No different than before. Same exact thing. Same exact thing is try to convert from one coordinate to the other coordinate. How much time I have? Okay, so we're gonna talk about a couple more things. We can talk about what if you times two polar number, like say z1 times z2. So this is a complex number, right? What if you have one complex number times one complex number? In terms of polar form, what will happen? Well, it's equal to R1 times R2, which is 2 modulus times together. And the cosine of theta 1 plus theta 2. And plus I sine of theta 1 plus theta 2. So that means the modules is going to multiply together, angle going to add. It's not as complex as you think. It's actually fairly easy. Believe it or not. I'm going to show you it's actually not as bad as you think. So we're going to take those two values, which is fine. And I'm going to show you that this is the two value we just found. We're going to say 2 minus 2i. 2 minus 2i. Right. We're going to times negative 1 minus square root 3i. And we're going to times those two together. I want to show you how things work. Now, you can multiply this by algebra, which is algebra 1. You can know how to do that already. In algebra 1, you already know how to do that. But we're going to prove to you polar form of the work too. And this is how polar form is going to do. The r is going to multiply by it together. Remember, we're going to talk about z1. What did we say z1 was? 2 minus 2i. And we're going to talk about z2 is going to be minus 1 minus square root 3i. Right? We're going to have this. What is the modulus for the first one? What is the r? What is the z? Absolute value z. What is it? Absolute value z here is 2 square root 2, right? So can I just, if I times 2 minus 2i, which is z1, and the negative 3 minus square root 3i is going to be z2. So I here we got 2 square root 2 is the first modulus. What is second modulus? 2. So can I just multiply this by 2? Thus 2r is multiplied together. Any questions there? And then it's going to be cosine of, well, what is the angle on the first one? 7 pi over 4, okay. Plus what? 4 pi over 3? Is that okay? Plus I sine of 7 pi over 4 plus 4 pi over 3. And this one is going to be 4 root 2. I'm going to do this on the side. 7 pi over 4 plus 4 pi over 3. This is 3 over 3. This is 4 over 4. So it'll be 12. 12. 21 plus 16 is what? 30, 21, 37 pi. So it'll be, okay, cosine of 37 pi over 4. Oh, over 12. Plus I sine of 37 pi over 12. I will put, let me see, what do they prefer? They prefer to put in the front. So what I'm trying to say is r is going to multiply together, put in the front. The data is just going to add together. So data is adding. Can somebody use decimals to figure out what is cosine of 37 pi over 12 is? I mean, you can use sum and difference to find it, but I'm too lazy to do that. So what's cosine of 37 pi? That's the same thing as saying, well, use radian, plug in, see what you get. Negative 1 point what?
1.2.
Are you sure?
Negative 0.96. Well, yeah.
No, negative 0.96 is, so 4 root 2 times, give me 3 decimal places.
0.966.
66? Okay, how about the other one? That's 37 pi over.
That one's negative.
Yeah.
This one's negative.
Yeah.
Okay, what's the second one?
0.259.
Negative what?
0.259.
0.259. So we're gonna say I like this. Is that okay? And this is just rectangular form. Is it distributed? If you distribute it, right? I don't know what is that number, but it's some of you guys can distribute for me. 4.4 square root 2 negative 9.66 is what? Negative something. No, I'm just show you how. I'm gonna show you in a second what does it work. Negative what?
5.46.
5 point. Give me one more digit.
4.6.
5 point negative 5.
4.464.
4 6 5
You're
That's one
rounding
tiny
down.
book back.
5 or 4.
Yes, you are, bro.
What is 4?
Yeah. 4645. You round one more.
4.64.
Bro.
5.464.
Yeah.
Right.
What?
Round up numbers.
1, 2, 3, 4. Bro.
It's a 4. It's a 4 4 6 5 4 6 4.
1, 2, 3, 5. You round up 4, 6, 5.
What is it?
Yeah.
It's 4 6.
Yeah. 5.465.
It doesn't matter, Mr. It's
5?
Yeah, it's one digit. Bro.
Okay. Okay. What's the other one? One more. One more. 4 square root 2. Can somebody come on? 4 root 2 times negative 0.259. What is it? 465 I. Is that okay? Okay. So let's try this and then multiply algebraically, which is the easy way, but you're gonna see that hopefully they come out to be the same. I actually never tried that before. I'm gonna try it. So 2 times negative 1 is what? Negative 2, good. What's 2 times negative root 3i? Minus what? Minus 2 root 3i. Okay. And then plus 2i. And then what? Plus 2 root 3i, right?
I want to be I
I
squared.
squared.
Yeah.
I squared, good. Good
Yeah,
question.
squared.
So this one's gonna be negative 2 minus 2 square root 3i plus 2i minus 2 root 3, right? So, okay. So it'll be negative 2 minus 2 root 3. Is that okay? This is the real part plus the I. That's going to be what? Negative 2 root 3 plus 2. Okay, can somebody work out a math of negative 2 minus 2 root 3?
Negative 5.464. Who was right, bro?
Bro, like.
Okay, what does this two number add together? Negative 2 root 3 plus 2.
No way. Negative 1.64.
So what is cool thing is the polar form, if we just multiply the r's together and the angle add together, it will come out exactly the same. But I just show you that algebraically they actually work it out compared to the polar format. So polar format will be able to do something very, very difficult. So I'm gonna give you one more equation, and you guys gonna guess. If I do z1 divided by z2, which is two complex numbers divided by each other, what would it be? R1 divided by R2? Is that okay? Because the same as before, right? So what do you think the cosine gonna be? Theta 1 minus theta 2 plus sine theta 1 minus theta 2, and that's I. Now, to be granted, you're probably not going to see too many questions, but on AP exam, you can understand that polar form, they can divide a number and the numbers subtract each other, it will come out be the same. And if you want to do this all over again, but division, you'll actually come out exact same number as before. So what is the point of doing this? What is the point of doing this? We are able to, hold on, let me get there. We are able to, using this idea, so imagine that if we have Z1 and Z2, they are the same number. Imagine you have two Z1. What would it be? This one will be what? They both are 1, right? And instead of theta 1 and theta 2, there'll be theta 1 times 2, right? So, what it comes down to, that there is something called the Morse theorem. And this is Z, let's say Z to the multiple power, to the n power, is equal to R to the n power, and the cosine of n theta plus sine of n theta. And this becomes this. Because imagine if we have Z times Z, right? Imagine if you have Z times Z. Would it be R times R? And the theta plus theta, so it'll be 2 theta. Does that make sense? And this becomes something called the Morse theorem. And the Morse theorem is going to be able to help you find certain things. I'm going to give you the whole overrun of this. I know I probably lose somebody already. Did I lose anybody? Imagine that if you have 2Z, they're the same number. Let's say 2 plus I times 2 plus I. Right? 2 plus I times 2 plus I. And if you multiply together, the R is the same, so R times R will be R to the n, right? So R to the square, right? And the data is just adding together. Whatever data, just adding again. So that's why it's going to cosine of this. So let's just say, let's just give you a situation, right? Let's say 2 plus 2i to the 4th power. Actually, make it fun. To make it 10th power.
We're supposed to meet.
Do you remember Pascal triangle? Do you want to do it to the 10th power? No, right? It's going to be very long. It's going to be from here to here and maybe from here to here because it's going to be 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, and 6 and 1. You see the point? I have to go to the 10th, but it's going to be very big Pascal triangle. Do I want to do that? No, okay, so that show you that this is actually solve this problem in very easy way. First of all, we just know that this is some type of Z. And Z is where? Z is 2 plus 2i. Right? 2 plus 2i right here. So this is 2 plus 2i. Would you agree? Okay, can you tell me tangent of theta of 2 over 2 is equal to what? 1. Tangent theta is equal to 1. What is theta? Pi over 4. We figure out pi over 4. Done. Okay? Got it? Okay. Now, what we're going to do is, once we figure out pi over 4, we know this theta is pi over 4. Do I know the modulus? 2 plus 2i is going to be square root of 2 squared plus 2 squared, which is square root of 8, which is 2 root 2, right? Okay, so we figure out R equal to 2 root 2. Now remember, we have a z to the 10th power. That means r is going to be what? 2 root 2 to the 10th, right? Is this okay? Cosine of how many theta? No. What is n? 10. So it'll be 10 times pi over 4 plus I sine of 10 pi over 4. Is that okay? Two to the 10 is 1024, and I don't know. That becomes a very easy number. You know what? That's not 10 is kind of big. I'm too lazy to do 10. Let's do 5. Is that okay? Do 5. Do 5, do 5, do 5. Okay, let's do 5. Let's do 5. This is to the 5th power. This is a 5. This is a 5. Is that okay? I just changed everything to 5. So what's 2 to the 5? 32, right? What's square root 2 to the 4? Square root 2 to the 4 is what? 4, right? 4 root 2. Is that okay? Is this okay? And this is going to be cosine of 5 pi over 4 plus I sine of 5 pi over 4. Is it okay? What's 32 times 4? 128 square root 2, right? Because square root 2 times square root 2 times square root 2 times square root 2 times square root 2. This is equal to 2. This is equal to 2. So it'll be 4 root 2. So what's cosine of 5 pi over 4? You guys know that. Cosine of 5 pi over 4 is negative root 2 over 2 plus I sine of, this is negative root 2 over 2. Is that okay? If I distribute, what will happen? 128 and 2 is going to be 64. 64 times 2 is what? Negative 128, right? Is that okay? Negative 128? Plus I. So it's going to be 128i. So I'm saying if you have, sorry, this one we didn't change it to 5. So we said 2 plus 2i to the 5th power is equal to 128, negative 128 plus 128i. Would you believe me? No. Okay. Get your calculator out. TI-84. I don't know if you can do it in decimal, but you can do TI-84. Do you have anybody have TI-84? Okay. I want you to do is 2 plus 2i to the 5th power and see what it come out to be.
Go down.
Sure. Because 128 and 2 cancel out equals 64. And 64 times square root 2 times square root 2, which is 128.
Can I see what?
Okay. 128 square root 2 times negative square root 2 over 2. I?
I found this.
You find it?
Does it fit?
Yeah. And press the equal sign. Oh, press the enter. Enter. I'm sorry.
Yeah. Oh, look. Negative 128
Because square root 2 times square root 2 is what? 2.
Why? Yeah, it's negative.
Oh yeah, I forgot. Yeah, it's supposed to be negative. Sorry. It's supposed to be negative. Okay, that's I have 5 minutes to recap everything. So if I want to do 2 plus 2i to the 5th power, do I want to do Pascal triangle? No, it's gonna be this ugly ass thing here. It's gonna be this ugly ass thing, but there's I to the 6th power, there's I to the 4th power, there's I to the 3rd power, there's I to the 2nd power, there's I. And remember, I to the square is equal to negative 1. I to the 4th is 1. So it's going to be very tedious as far as the sign mistakes you're going to make. So what we come up to be is we come up this idea is if complex number divided by each other, the modulus is going to divide it by each other, theta is going to subtract each other. But this is not the one I care about more. I care about this one. This one just say if two complex number times each other, the modulus is going to multiply with each other. And the theta is going to multiply by how many thetas. So what does this mean? Imagine that Z1 and Z2 are the same. This R1 and R2 become the same. So it'll be R to the N. Now, what happened is we come up with this formula, which is if I have a complex number to the n power, that's going to be R to the N times cosine of how many theta are they. Because if it's fifth power, then it'll be 5 times theta. If 4, it's going to be 4 times theta. And this is sine of 4 times theta, or whatever. And then what happened, you're going to get result into a very easy way. I have a student in the past. His name is Gianluca. He went to Caltech, which is second best technology college in the world. Besides MIT, there's a Caltech. And he worked out 2 to the 2i to the 10th power. He spent 38 minutes on the board and I let him work out. I did not say a word. He worked out everything. He filled the whole board with all numbers, with the Pascal triangle. He spent 38 minutes to finish this. And he got really mad at me because I showed him this way and I did it in 2 minutes. And then he says, he literally cussed me out. He literally says, fuck you, Mr. Ye. Like, you make me spend 38 minutes, but I'm just trying to say, sometimes math, there's an easy way to do something. And I know he would get a right answer. I knew he would get a right answer because he's super brilliant. I can't even get a right answer because I'll make some mistake on the side. He's super brilliant. He's also super good as well. So he filled up 2 boards and he found out the answer. And I just did it. I show him the Moore theorem. The math, there's always simple way to look at things if you understand more. The solution could be as much as just this, as opposed of 2 boards that fill up with all math. Anyway, that's my story. End of the day. What are you looking for? No. Go redo your test.
What?
Go redo your test. Don't look
That's
at
what
your
I'm
test.
looking for.
Don't look at your test.
I'm not looking for my test.
What are you looking for?
Do you have like a paper one?
Do I have a paper one? I don't have front and back. Maybe this one. Yeah, I don't have front and back. He already took a picture of it. It's on a group chat.
Okay.
Okay, who need to explain who need an explanation on Ferris wheel questions? Okay, Winston, go.
1 minute.
Okay, go to him. Go to him.
I want to stay here.
Huh?
I'm staying up there.
You staying after? Okay. Oh, Winston, you had to go?
Yeah.
You can do it. You can do it.
Well, like, I don't know, like,
Wow, it's so resourceful of you.
It's pull.
this is my thing.
I found a very good eraser.
Thank you.
I don't know whose jacket is that.
No, I think you got that. What did you buy this? I don't know if you got that in like COVID. No, I don't know. Dude, what's the book?
Okay, so what's it?
Tell me what it is.
Bro, Alex, if I click on this reel, what am I gonna see?
Oh, I don't know. I don't know. Oh, wait, now, like, oh, you're looking at it. It's like you're using it like that. I feel really well.
Let's see what Alex sent me. Alex, you should stick around. Let's see what you sent me.
He's just mad.
I'm not. Yeah. Don't use your jacket.
It didn't say the high cover for it?
Yeah, yeah.
I
What's the wrong with you?
What?
No, I know. I'm not gonna back. I don't know what you sent
From
me.
the test.
That's not.
It's like not showing up in review behind it.
Bro, that's fine. I'll just pull it up on your phone at this point.
It doesn't have the back on it.
I don't know. He sent me
But
something.
like,
It's 5 feet above the ground.
Oh wait.
So,
No, this is what I
right
saw
here,
earlier.
This is 5 feet above the ground. The middle of Ferris wheel. So the amplitude is 40 because it said the radius is 40.
Yo, the
From
girl.
the middle to the outside of the circle is 40. From here to here is 40. So you're not starting at the ground. So this has to be 45
How long you guys know each other?
right?
I've
This
known
is
you
45
since-
feet.
like know of or like
I've heard like you guys like a
So add 40 more, and it's 85
okay,
feet.
it's because
I've known Alex.
you don't know him,
for
but
Yeah.
it's the guy that goes to DB now. Bridge.
Yeah.
Oh, you know? Yeah, Bridge is cool.
Oh,
So
kind.
I know you put separate. Yeah, you had.
you already have amplitude, which is 40, right?
That was in Bridge too.
Yeah. But like,
Pre-op, right?
So-
You off over second.
I did actually.
Remember,
Okay, second grade.
a sine wave
Oh my God, I know.
I think it's been like
from the midline.
sixth grade. Because you went up to
Yeah.
Yeah, no, I was.
Most sine wave starts
Yeah,
from
we
the
couldn't
peak
get it, honestly.
and
Like,
it goes down
Yeah.
to the midline.
I've known him since
Yeah?
second grade.
I know.
Okay, so when you ride a Ferris wheel, you don't get like on it at the middle of it, you get on it at the ground. So
Yeah, you know what?
you're not getting on it at the middle of the you're getting on it at the bottom.
Digital.
So think of this as a cosine wave. You're starting here, going like this. Yeah?
No, 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 it's not that. It's like
So
none of them.
it has to be
All of them
negative 40
were like in algebra.
Yeah.
one.
Okay, Alex. I see how it is.
I'm gonna leave.
Yeah,
One
I see
revolution
how you are.
in 60 seconds. So one whole revolution, so one whole wave,
Successfully got my
60
back.
seconds.
Bro,
How do you find
I mean,
the period of what's the formula? Okay, so 60
like, what are the
equals 2 pi over v. Cross multiply, multiply, 60
Can I come to school tomorrow for the exam?
You cannot take a Saturday?
Why?
Not
Yeah.
your but 4 minutes. Going somewhere.
Okay, that's fair.
So this goes to